Hello, ladies and gentlemen. I hope you are doing great. Today's lesson is on the internal rate of return. We're going to look at this particular topic in connection with the selection of an investment as to either you can proceed with an investment or not. So we'll look at how you decide, and then we may also look at the calculations. So what we're going to look at is we define what the internal rate of return is. Then we look at the selection rule that is involved when you're using the internal rate of return. Then we're going to look at the two methods that we use to calculate the internal rate of return, or to come up with the internal rate of return. That is, we're going to use the plotting method, and we're going to use the trial and error method. Now, what is the internal rate of return? In simple terms, I would say the internal rate of return is the discount rate, where the net present value is equal to 0. So if you use a particular discount rate to discount a project, and then when you calculate the net present value, you find that that net present value is equal to 0, then it means that the discount rate that you've used is the internal rate of return, or is equal to the internal rate of return. Now, there's a certain rule that is used when you are selecting a particular investment, a particular project, because you have to rely on something to tell you that this particular investment is going to be profitable, feasible, or whether it's not going to be feasible or profitable. So what we normally rely on is the internal rate of return itself, and then we compare this internal rate of return with the cost of capital. So if it happens that the internal rate of return is greater than 0, or rather if the internal rate of return is greater than the cost of capital, then you have to accept the project. But if it is less than the cost of capital, you have to reject the project. It means that the project is not feasible if the internal rate of return is less than the cost of capital. But if it is greater than, then it means that the project that you're about to embark on, or the investment that you want to undertake, is a feasible one, and you have to proceed with that particular project. Now, it's important that from the outset we understand how the internal rate of return is calculated. So we are going to begin with the plotting method. Of course, I did mention that there are two methods, the trial and error method and the plotting method. So in the plotting method, what you make use of is the NPV and the discount rate. We have to plot these on the X or Y plane, and then once we've plotted the graphs themselves are going to tell us what the internal rate of return is. Okay? So where the graph crosses the NPV that is equal to 0, okay, or where the x-axis where the axis is crossed by the graph that you plot, that is the value of the NPV, okay? Or rather the value of the internal rate of return. I'm sure you're going to see what I mean, okay? I'll explain as we come to that particular graph. And then we have to bear in mind that the internal rate of return is normally expressed as a percentage. So, for us to understand very well how we proceed with this method, or how we proceed with the calculation of the internal rate of return, and how we use it in project selection or in making a decision as regards to what we're going to invest in, it's important that we look at a question, and this is the question that we're going to look at and work out the internal rate of return. So the question says, a company wants to buy new machines for a 4-year project. The manager is required to choose between machine A or machine B. So there are 2 machines that are involved, and then the period of time is 4 years. The machines have the same initial cost. The initial cost for these 2 machines are the same. It's $35,000 US. But their cash flows perform differently over the 4-year period. I'm sure you understand that. And the interest rate or cost of capital is 20%. So we have to bear all those points in mind even as we calculate or work out this particular question. Now, we're going to look at machine A, that is at 20%. So this is the work for machine A. I'm sure you can see the initial costs that are involved. In year 0, you have in year 0 you have $35,000 US. Okay, and those were the initial costs. Okay, or that is the investment that is involved, and then you have other values underneath. So what is important is you need to get the discount rates of the years that are given. And once you get the discount rates, like I explained in the previous lesson, you have to multiply the values by the discount rates in order to get their present values. Okay? So I'm sure you can see where I've written present value, the CFDF, meaning you get CF, you multiply by DF, and then you get the value. So that is how you get the values in the last column. You multiply CF for cash flow by DF, which is the discount factor. Now, after we multiplied, of course, it's clear that the NPV is positive, 2,692. Now, for the sake of plotting, this may not be a good one. So we will continue working out. So what we do is we raise the discount rate. And the reason why we're doing this is because we want to lower the net present value. If we have a negative one, the better. Okay, so we have a negative one and a positive one. Okay, so these should be successive values, the positive one and the negative one, and then we use these to plot together with the other values. So we have 24% and 25% as our discount rates, and these are the values that we have. I'm sure you can see them. We have $361 and we have negative $184. That is after working out. Now let's look at machine B. Of course, we'll plot them together. So since we've calculated for machine A, we now go to machine B. So for machine B, we are using 20% and 19%. And at 20%, we've already seen that the net present value is already negative. If we lower it rather to 19%, since we want to raise the discount rates, you can clearly see that again the net present value is negative. Okay, so we'll continue lowering the discount rate so that we get a positive value. And I'm sure you can see that here what we have is a positive value. Okay, after raising the discount rate to 18%, so the discount factor to 18%, the discount rate okay, to 18%, we get the net present value of $102. Now, after we've got all the values, then we have to tabulate them, like you can see below. We have tabulated. So for machine A, those are the values that you have. The NPVs for machine A, and for machine B, you have them in the third column. And the first column are the interest rates or the discount rates. So once you've tabulated out, the next thing that you need to do is you need to plot. So after plotting, this is what you're going to get. So this line, the colored line, is it orange? Okay, it should be orange. That is for machine A. That is the curve for machine A, or the graph for machine A. And then for machine B is. So as you can see, these values on the y-axis are the NP values. And then just along the zero line, or the zero axis, x-axis, that is 0 NPV, you have the values for the percentages. Okay? So where these lines cross the 0 NPV line, that is where the internal rates of return lie. I've labeled them just to make it convenient. So for machine B, the internal rate of return is 18.1%. Then for machine A, the internal rate of return is 24.7. So we can now proceed. I'm sure you can easily make a decision. Okay, if since machine A, the internal rate of for machine A, the internal rate of return is greater than 20%, then it means that is a viable project. But for machine B, it's less than 20%. So which means you have to discard that one. It's not going to be viable. Okay? Let's look at trial and error method for calculating the internal rate of return. In this method, we use this formula for internal rate of return. That is, we've got L, which stands for the lower discount rate. H stands for the higher discount rate. NL is the NPV at the lower discount rate, and NH is the NPV at the higher discount rate. Then, for the sake of illustrating what I've just gone through, if we look at machine B, we have $102, and this is associated with 18%. Of course, 18% is the lower discount rate. So $102 is the NPV at the lower discount rate. And then we've got 19, which is the higher, 19%, which is the higher discount rate, and negative $660 is the NPV at the higher discount rate. So that is how you use that formula when you're working out. Okay? So we ignore the other negative 1,000 etc. That one is ignored. The same applies to machine A. We're only going to consider $361 and negative $184. Okay? And then we apply the higher, lower discount rate respectively. So let's go to the next panel where we've done the calculations. We have the calculations for machine A, and the answer that we've got is 24.66%. Of course, there's a table on your left-hand side in the top corner of the panel. That is just for the sake of making it easy for people to follow through. You can easily see which values are picked from the table according to which machine I'm calculating the internal rate of return for. Okay? So for machine A, of course, the values I've picked is 364 and 184, and the percentages are 24 and 25% respectively, and then I've worked out. And the value that we got is 24.66%, which corresponds to what we got in the plotting method. Okay, of course we got 24.7, which is just as good as 24.66%. If we round off, we still come to 24.7%. And then for machine B, we've got 18.13%. If we round off to one decimal place, of course that would be 18.1%. So that is how you work out the internal rate of return using the trial and error method. And then for a decision, we have to refer to the cost of capital, since we had 20% in the example as the cost of capital. So since 24.66% is greater than 20%, then it means that machine A qualifies for further consideration, meaning it can be funded, it can be picked for investment. And then machine B has failed the test. You cannot invest in it, it's not feasible. So that is all based on the decision rule, which says that the internal rate of return has to be greater than the cost of capital for you to invest in a particular investment or project. And then if it happens that internal rate of return is less than the cost of capital, like is the case for machine B, then it means that you can't invest in that. So with this, we end today's lesson. I hope you understood or you picked something from this lesson. I'll see you in the next section.